we'll do is at this stage we'll start off with the session by Abhijit. I'll briefly introduce him, and then we can start off with the session on predictive analytics. And at the end, of course, we are going to have a Q&A again on Abhijit's session. And at that point of time, in addition to predictive analytics, anybody has any further questions on cloud computing, those can be asked, subject to our time frames that we have for this HOA. Now, briefly to introduce Dr. Abhijit Sanyal, he's got a DBA and a whole lot of theoretical background as well as a great deal of experience in predictive analytics and analytics. You can look up his detailed profile on Google Plus as it is available. But without trying to stretch a point, I think if you look at the field of analytics and predictive analytics, I would put him as one of the persons who has, one of the most extensive experiences ever since this field kind of got defined and opened up. So, having said that, I'll put you on to. I'll hand it over to Abhijit to start his session and take us through his presentation on predictive analytics.
Hello, can you guys hear me?
Yes, Abhijit, over to you.
Okay. Thank you, Raja, for the wonderful introduction. So let me share my screen. Just tell me if you are able to see my screen. Can you see my screen?
Yes, we can.
Okay. Yeah. So yeah, by way of background, I've been in the predictive analytics space, or analytics, what you call marketing science, data science, before it was fashionable to be so, and that was for the last 25 years. And me and Raja go back to when we were actually kids, I think, in college. So it's a long history.
Yeah.
So the idea of predictive analytics is the history of it is it comes from various strands, and I can give you a very brief. Some of you maybe have worked in, say, the area of statistical modeling or mathematical modeling, and it goes back to, say, the work done by Francis Galton, and then Carl Pearson, Ronald Fisher, the guys who basically invented, say, the idea of correlations and regression models, analysis of variance, etc. And one of the issue was that in those times, all the calculations had to be done by hand, and the data literally had to be stored on paper. What has changed in the last, say, 10, 15, 20 years is that data storage costs have been dropping dramatically. Computing power has increased enormously. So some of you may have even seen a movie on Alan Turing, and that was in World War II, when Turing and his team at Bletchley Park were able to basically crack the Enigma code using using various algorithms and Bayesian approaches, etc. And I think that was the kind of quote-unquote start of predictive analytics. Most of it by the UK and the US governments, and even the Nazi government, using all kinds of analytics for the purposes of war. So having said that, the idea right now is that it's become pretty much mainstream, and there is so much huge volumes of data generated, especially through, say, the Internet of Things, that we are actually swamped in data, and data without any analysis and without any insight is quite meaningless, right? So let me try to also give you some perspective on and bound the topic, because data can be of broadly two kinds. Data that is in what they call in rest, which is essentially static sources, and the data in motion. We're not going to talk about data in motion, which is essentially streaming data and things like that. The other issue also is that the data sizes have become not in even gigabyte. 1 gigabyte is a small data set right now. It's in the range of petabytes and terabytes and zettabytes, etc., etc. And to handle those kind of models, or build models around that, or algorithms around that, you really need a totally different approach, because here, one of the things, as I said, was earlier on, data collection and data acquisition was extremely expensive. And so in that case, what was happening is, the whole idea of analytics was becoming sample size, excuse me, sample sizes was an issue, but right now, samples are no longer an issue because data is being generated literally as if you're drinking from a fire hose, as they say. So coming back, kind of bounding the topic, this is what, I think we'd like to discuss today, give you a process overview, understand, what is the business and the hypothesis development around it. You go to assessment and understanding of the data, ingestion and extraction, data preparation, modeling, evaluation, then finally deployment. We won't go into details in all the topics, but basically at least it gives you an overview of the process and what it means. So let's kind of define what is predictive analytics. So it's essentially the smart use of a variety of data sources, statistical modeling, and algorithms to provide insight. That's the key thing. And it's evidence-based, proactive, and dynamic. So a lot of you folks might be doing some reporting, right? So, reporting essentially says what happened. And alerts essentially say that, what actions are needed now. Basically, okay, this was, our sales was down last month, therefore we need to do something about, coming up with, increased effort to increase sales. Why is this happening? What's the analysis? Why was sales down? Because was it a weather issue, or was there was a competitive reactions in the specific territory, etc. Why is that happening? The predictive modeling basically goes into questions like, what will happen and what's the best thing that can happen? How can we optimize sales in the future, basically by maybe, changing our value proposition, changing our promotion, sales force incentives, etc. Right? So again, this gives you a kind of a maturity curve, if I may say so. So essentially, you start with raw data in the left-hand side, and you clean data reporting, online analytic processing, all apps and ad hoc reports. You go into generic predictive modeling, then finally optimization. And the maturity within which an organization resides in basically ranges from the left to the right. That is simple to complex. So what are the applications of predictive analytics? This basically is a very high-level snapshot, for example, in demand planning and forecasting, product optimization, various applications of marketing science, tailoring and targeting value propositions, supply chain logistics, optimization of machines and things, mathematical modeling, revenue management. For example, there are companies in the US that are using weather station data to kind of come up with insurance programs for farmers. So, recommendation engines, whenever you use the Amazon or the Flipkart, buy products from there, basically they come up with some recommendations for your next product. How do they do that? They look at your past purchases and then come up with, like purchases that you may like over the next, on your next purchase. Workforce analytics and learning, how do you can link employee and customer satisfaction? How do you recruit your best employees? How to retain them? And there are even things like, text analytics and social network analytics, etc. The whole field is exploding just because, as I said, costs of data storage have gone down. Data is available in the gigabytes, and analytics, all the procedures are also available. So the other thing that you may have heard is the idea of what they call what they call the whole idea of sorry, one sec, excuse me. Yeah, so the whole idea of machine learning as well. So, this particular slide is very, very high level. It tells you, what are we talking about? We talked about data in rest, data in motion. We can even divide the data group into, what we call structured data, where it exists in fixed fields, and unstructured data. So unstructured data is text, web pages, images, photos, videos. And even with unstructured data, the whole idea is to take those, say, web pages or those images and pixels and essentially create structure out of it, because you can't really, ultimately you have to create structure out of even any kind of unstructured data. And very broadly, predictive analytics kind of consists of two. Most procedures can be classified into two. One I would call as regression, or essentially estimation of predicting quantities, and the other one is classification. Which group will you fall into? Like segmentation is a classification problem. Then, there's not much difference between predictive analytics and machine learning. People use these terms interchangeably. I mean, machine learning is really when you start dealing with very, very large data sets and the whole set of algorithms have to change. And so supervised learning and unsupervised learning are two terms you may be familiar and heard of them. So in supervised learning, essentially regression, for example, is a supervised learning because you know the right answer. In unsupervised learning, you kind of have to discover structure in the data. So that's a much, it's a little bit harder problem. Sorry. Right. So if I were to basically summarize here, what's the process? How do you go from, say, starting a predictive analytic project and go and come up and then finally end in the deployment? I mean, this is a very busy slide, but let me just give you some at least overview. So, you start off with the business understanding. What's the objective? Then you go into, say, the data assessment and understanding. I mean, I think, Sukumar talked about, say, what are your regulatory requirements and where does the data reside? So those issues are also very important here. Data governance, data ownership, whether the data is rest or in motion, data size, average or extremely large data sizes, and data typically is across multiple tables. So, I mean, those of you who have a, a database background, you'll know that, you need an entity relationship diagram and you need to link these tables up. You need to synthesize and, extract the data, which is actually a very important task. So then you go into data ingestion and preparation, and you have to talk about, how do you extract the data, and obviously in the last few years you've heard these terms like Hadoop, Scoop, Hive, and Pig. They're essentially all kinds of add-on kind of bolt-on SQL-like kind of programs essentially that are on the Hadoop platform, because typically Hadoop and MapReduce, which actually has to deal with very, very large data sets, is not something that is easy for programmers to start working on. It's fairly difficult. So, and then you go into the modeling. And in fact, let me also kind of tell you that the business understanding, assessment, and ingestion and preparation and extraction for data, that actually takes about 80% of your project time. That is actually really the critical and the most important piece. Most people think that modeling is the fun thing, which is true. Modeling is fun. Modeling is where you really can do a lot of great work. But modeling actually takes about 20-25% of your effort. Then there is evaluation and deployment. And that is also critical because most companies, they do the models and then it sits on the shelf without actually being deployed. But there also you have to think about, what's the baseline measures, how do you measure the success of the model, how do you change, how do you work with the IT solution architecture, what do you need to do it, how do you define the workflow? How do you, user acceptance testing, et cetera, et cetera. All those things have to also come into play, which is very critical in this whole piece. Let me take you to the next slide, which is just a very high-level kind of case study. And this was for product line optimization in the industry, in the computer industry. So, as you know, at one stage, laptops were available with many, many, many combinations, and the idea was to kind of decrease product proliferation because there was a lot of unnecessary products floating around in the market. So the objective was to launch a limited set of models to maximize profit revenue, identify price points. And how do you do that? You basically they went into the channel and they surveyed all the channel reps and the whoever basically selling the product, and basically work with user and use product and market scenarios. So this is actually slightly different from what you would do in a big data project. This is a small data project. Experimental design was used, discrete choice modeling, and then finally you come up with a revenue optimization. And as you can see, before the curves were going downwards, and after these things were implemented, things turned around. So what with the back end, what you do is essentially you provide the client with a strategic tool for launching simplified customer focused product offerings. And this is a pretty old study. This was done about, say, 10 years ago. And even then, when I checked with the client some time back, they were still using this particular study with minor variations to kind of refine their product portfolio. So, Raja, I can turn it over to you, and you can see if anybody has any questions or things like that. I kind of rushed through it, but
Yeah. Okay. No, I think it was I mean like you said, and like I like to stress as well, that predictive analytics, machine learning, big data, these are it's a vast area, and it's rapidly developing and evolving. So to try, and I think Abhijit, thanks for giving a great overview in a space of 15 or 20 minutes. In fact, I think that's one of the very difficult tasks, because there are courses, and there are very extensive courses which go on for 3 and 4 semesters on these kind of topics, and that's what it is about. And there's new applications, tools, knowledge areas getting constantly added to it. It's still very in its very early stages. I mean, big data, machine learning, these are possibly just about getting mainstream now. Having said that, maybe I'll kind of I have a few questions which I'd like to ask, but I'd leave it to Subhamoy to start off with any questions that you have, and I'll meanwhile just check if we have any online questions we have come in.
Yeah, I have one question here. What we see is the data quality at times is not pretty good. So, I mean, how do you see it in other organizations? Is data preparation a big part of the task, or is data already available and you do the analytics on top of that?
Subhamoy, I think you've hit on the biggest problem in this whole field, and that is how do you maintain quality, and the amount of time that it takes to kind of get quality up to a point where you can start using it for analytics is actually typically under-resourced and unknown, right? So you're right in the sense that one of the biggest problems is with data is missing data, right? So you think there is data, but actually there is no data. So there are now algorithms that essentially are able to handle sparse data across extremely large matrix operations. And if you really want to become good in predictive analytics, you really need to know your matrix algebra very well, because most of these cases are actually all actually involve very large-scale matrix inversion algorithms. And you're right about the data, which is a very painful process. And I've come across most of my issues actually have been with trying to estimate the data quality, trying to work with the client to kind of not only understand data quality and how we can improve it. And typically that is where actually it's no longer a data issue. It's actually an issue of talking to different people who own the data, and to talk to them, one-on-one, as to how do you improve the data as such. And this is something I think is going to be a continuous problem for everybody going forward, is how to improve the quality of the data. Very good question.
Thank you.
Any follow-up questions or other questions, Subhamoy?
No, I mean, what we see is, see, for example, in our organization, we have a lot of customer data. But how do you define the quality, and how do you measure that in an ongoing method? That sometimes becomes a bit fuzzy. So do you have any idea on that? For example, customer demographics. How do you want to measure the quality of that data?
Right. So typically what is done, I mean, this is you have to essentially triangulate data. So you have, say, a customer database where you have collected some demographic data. You'll have to essentially spend some money and collect some, actual survey data. So let's say you have customer A who says he's 35 years old and, is a male and therefore works in, say, this industry and has, 2 kids and whatever it is, and so much income. So actually you have to then go and get a smaller sample and actually survey people and talk to them and get actual data, and then do a one-on-one comparison with what your customer data is showing and find out what is the level of accuracy. What I have found is, it's very interesting, is typically the level of accuracy is actually in the range of 70 to 80%. So you can actually use their algorithms which based on your product usage, product purchase, and transaction behavior can actually predict demographics. You get the idea what I'm saying? So it basically uses the data to kind of predict which likely demographic group you will belong. And sometimes that is good enough for your kind of whatever strategic programs and tactical programs that you want to develop. Have I answered your question?
Yes, I mean, if we keep on asking questions, that will be like hours to go. So I will leave it to Raja to continue.
Sure.
Yeah, Abhijit, my question is more about possibly a fairly related area, which is about big data, machine learning, and so on. Now, there haven't been too many projects, I guess, even in the US, and I guess in the Asian context, the number of projects possibly can be counted on one finger, if at all. Now, my question is that in most of these cases, you're churning all that data. You're looking at the whole data set instead of just a sample and so on. And at the end of it, one is finding out certain correlations. I mean, it could be a strong correlation or not so strong a correlation and so on. But this, in most cases, it does not tell you the causality. Now, is that an area where some organizations are saying, no, it is not good enough for me just to know the correlation, but I must also understand the causality, because that, I understand, is the more difficult part, and something that may not be very apparent when you do a big data analytics and kind of come up with certain correlations, and that you figure out at the end of it.
Yes, you're right. I mean, causality is always a problem. As you know, there are certain basic principles to kind of sufficient and necessary conditions to prove causality, right? So the cause must happen before the event, for example. There must be a time lapse or something along those lines. And there are other rules that define causality. Now, that is always an issue, and that is always something that most analytics practitioners kind of, I would say, struggle. But at the same time, we have to use our common sense to try to come up with why something is behaving in the way it is, right? And I think, going back to my experience, I always find that there are certain models you can build which explain things very well. So if you essentially do a simulation, for example, one of the classic things is, if you increase price, your demand should fall, right? And or if you essentially increase the promotion of your products, then essentially your demand should go up to a point, and then it may fall again. So there are models that explain very well, and there are other models that don't explain very well, and they're essentially black boxes. I mean, the other example would be a neural network, which essentially is what they call an over-parameterized model, which, if you look at what they call the parameters or the constants, it's impossible to understand why the model is working and doing well. And some of you may have heard of the Netflix competition. The Netflix came out with a $1 million prize, which was, I think, ultimately won by an IBM team. And they actually use something called ensemble modeling, which means stringing together 5 or 6 different kinds of machine learning models together, cascading them. And if somebody went to ask them, why is it working, it would be very hard to explain that, right? So, that is a conundrum in this particular space, and I think it's always going to be a problem, is to try to always define causality as such in a very clean and clear fashion. So, am I making sense here, guys? I mean, I don't know.
I think so. I think that's a difficult area, and that still remains a great area. So but thanks for that explanation. I think given that, I think this is a very lucid way of kind of putting things. Just a point to those who may be viewing this, on YouTube or on our homepage, where this is also being live cast. Um, if you do have questions, you can use the Q&A app, or you can use the button which you see on YouTube to put in your questions there, and we'll try and pick them up and get them answered by either of the speakers. That is, if your question is pertaining to predictive analytics or cloud computing, one of these two areas. Also, just to mention that we do conduct periodically, corporate workshops, where we go into a lot more detail, which will not be possible to cover in such a short session or in a hangout. You can keep your other questions coming in, because we do have some time, and we can pick them up and do that. Meanwhile, I'll just pick up a question posed by Sunil Karve, which you can see. If you switch on your Q&A column on the right,
Right.
I'll just read out the question as well. The Sunil Karve's question is, he says, Abhijit, what methods and techniques typically go into the analytics, for example, regression, etc.? That's the question.
Yeah, so when you say what methods and techniques, I'm trying to understand the question, Sunil, because regression is actually a method, right? So as I was saying, broadly, most of these predictive analytics problems fall into two classes as such. One is predicting quantities, and the other is predicting classification, which group you will belong. Going back, so let's take that tree down further just to try to answer your question. If you say regression, and that is essentially also called supervised learning, right? Most of these problems actually become, if you think of it simply as y is a function of x, a left-hand side trying to understand what the right-hand predictor should be. And there are very many ways to do that. So, regression is one way. For example, logistic regression is another place where you kind of understand, say, a dependent measure, which is maybe a 0-1 variable or a nominal variable. And those are the kind of details that obviously we'll have to do in a workshop. But there are support vector methods. There are all kinds of, say, other methods that basically go into this particular problem of regression. But regression is just one small, not small. Regression is possibly the most important piece of predictive analytics right now. But what is really important is what is called, how do you understand the predictor or the driver variables that will predict your dependent measure, which is, say, either your purchase or choice, or it could be, say, component failure of a machine, failing versus not failing. So have I answered your question, Sunil? I think we can go into a lot of details in one of these workshops, but it is a very good question. Thank you.
Sunil, if you're viewing, or if you want to kind of join in, we have space in the room, so you could join in. Or if you want to ask a follow-up question, you do key it in, and we'll try and pick it up from there. Meanwhile, Subhamay, do you have some other questions on the topic?
No, I will leave that out. I mean, there are many questions, but I will possibly keep it for future.
Hey Raja, I think somebody has joined a question. Maybe it's you, about the case studies planned to be discussed are the Asian ones, and that's a very good question.
This was an offline question, which in fact I think we had put in, and because I thought we thought that this was also specifically for a lot of Asian viewers and Indian viewers and so on. So therefore, there was a question about would you be discussing any Indian case studies? And I think Subhamoy did discuss an Indian case study in terms of cloud computing. But would you have any Indian case studies you can refer to briefly in this area?
I can refer to them as anecdotally. I mean, there are some work being done in the finance. I mean, you must understand one thing is, I think it was this famous guy, basically a bank robber. He said, "Why do you rob banks? Because that's where the money is, right?" So to a certain extent, where do you go for data? Because you got to find where the data is. And right now, I think India is, possibly in the same situation as maybe 70s or 80s in the US, where US was in the 70s and 80s. So there's a lot of data being generated, I think, mostly in the financial services and transactional area and places like retail. And also, I think, say in places like telecom. So those are the 3 or 4 sectors where I know there have been some work done, especially in the field of telecom, trying to use, say, um, and predict essentially what's the kind of phone and what's the kind of phone you will purchase, what products will you purchase in your phone, and etc. Things like that. And also in the area of, say, mobile marketing. So these are very, very nascent areas right now. And as far as I know, there is some work being done also in the banks where, uh, for example, some of you may have heard of things like credit scores, right? So, right now in the US and even in most Western nations, there are very formalized credit score, which basically put you in a specific credit bracket for your ability to pay off loans and take loans and, etc. So I think India right now has some level of work going on at that consumer level. So that's my knowledge so far. But I mean, I think many listeners may have other experiences too. Go ahead.
You're right, possibly. I mean, we do have some of the credit bureaus, US credit bureaus also, who do credit
Right.
scoring in India. And yeah, I mean, the database is getting built up, I would say, because
Right.
for credit scoring, you need the source of data to a large
Right.
extent.
And you need history. You need a long history. You need about 10 years of credit history to say that, okay, and that is being built up right now as we speak.
Yeah, people like Sibyl and Experian are setting up credit scoring here also.
Right. Exactly. Yep.
Devashish, a belated welcome. This Devashish Guha, whom I have known for years, and Abhijit, you possibly know as well from our IIT days. Devashish, I think himself has been kind of working in some of these areas for some time. So Devashish, possibly you'd have a question for either of the speakers.
Actually, I haven't really joined earlier, so I don't know what went down. So offhand, I don't have a question.
Okay. Basically, I think there was about a short talk on predictive analytics by Abhijit, and before that, Subhamoy did the same thing for cloud computing. So, if in general you have any questions on any of these areas.
I guess I have the same question that you asked, and predictive analytics. Where are we in India with respect to predictive analytics? I know that Abhijit already gave some response to that, but one area where I have been working, and that is in financial markets. There is, of course, enormous amount of data that's produced by the markets, and that is one of the uh, application areas of predictive analytics. My understanding, so far as I know, is that it is not really being used in a extensive way for market prediction in India. Maybe Abhijit can comment on that.
Debashish, when you say market prediction, are you talking about stock market prediction?
Stocks, bonds, currencies.
Yes. Oh, very good. Well, we know what happened in 2007 and 2008. All those quant models went over the transom, right? And there was complete disaster. So one of the things about stock market prediction is that it's very, very difficult in my opinion. And one of the things specifically, I think, in the Indian markets you have to think about is the level of liquidity. So a friend of mine, for example, is doing some work in Singapore using, say, the Singapore stock market, or essentially Asian stock markets. And in Singapore, for example, there is the financial, and you must have heard of these guys, the Temasek. They own a lot of stock in a lot of companies, and there's hardly any liquidity. So even if you come up with a model, the model is of very little value because there's so little liquidity in the markets. And anyway, so coming back to the stock market problems, I think India, it's a very difficult problem right now in the US. There are firms I know who have started work. In fact, I know professionally quite a few people who do things like this high frequency trading, right? So essentially you have a model that predicts based on the number of ticks in microseconds. So to the extent that there are some firms that actually site their data centers close to the New York Stock Exchange, and the length of the utility pipe is actually one factor that determines whether you can make a profit in the market. So it's in that level of literally microseconds of trying to get ahead of the game to try to predict profits and use. And the models there are very simple models. Essentially, all they do is say before somebody else gets to react to a certain market information, they essentially have made a trade and got in and got out. But all this is very, very I think in the Indian context, high frequency trading, I don't think really exists right now. And it's a very difficult. There are some hedge funds that have basically in the US have started doing, say, using big data and data sciences. I don't know how successful they have been. And most of the people who have been successful in the US actually have used models to kind of uncover market inefficiencies and therefore make profits. For example, there are people who have used, say, the utility rates essentially sometimes spike because of various weather and other patterns and etc., and make profits in the utility space. So I'm coming back to your question about the Indian stock markets. I don't know. I think there are a lot of regulatory issues and other issues that need to be resolved before you can see that. I'm rambling. Sorry. I was just putting my thoughts together.
Let me just add to that. Actually, server co-location is very much available in India. Both
Right.
Bombay Stock Exchange and the National Stock Exchange offered this service where you can co-locate the server on the exchange building in the next room.
Right.
So the length of wire is around 10 meters, which is obviously very important, as you pointed out. And there are in fact high frequency trading firms in India, mostly in Mumbai, of course, but a few I believe in Delhi. I don't know exactly how prevalent it is. The current estimate is that as much as 30 to 40% of the trading on the National Stock Exchange may be generated by algorithmically. So apparently this is come in a big way even in India. I don't know, the provenance of these stories and whether to believe them, but these are reported in the financial press. In terms of algorithms being used, as you correctly pointed out, they tend to be very simple, and in India also I'm sure that is the case. However, to what extent the methodology remains the same to what extent it is even regulatorily permitted, these are questions that certainly I don't know the answer to.
Yeah, I agree with you. I think a lot of this is actually we'll never know because a lot of it's mostly very obviously company confidential. So
right, exactly.
Okay.
Yeah.
Sorry. Yeah, I think we coming close to the end of the time that we had scheduled for this. Maybe I'll ask one last quick question, and if there are no other questions offline, at the end of that question we can wrap up the session. My question is essentially, Abhijit, I think one of the dilemmas a lot of people who face, who want to get into this, who want to into these areas, is that they can't find they do not know where to find all the data that they need. They do not have the human resources that they need to do this in-house. and somewhere these two factors kind of defeat a lot of people and they give up. But at the same time, I have heard a lot of people saying that since a lot of this data is very sensitive and a lot of this data is internal data and so on, if they do not have the resources in house, they are also reluctant to go to an outside consultant because of the sensitivity and the confidentiality of the data. They would not quite trust an outside consultant to kind of have access to that data. I mean, despite confidentiality agreements or non-disclosure agreements and what have you. I mean, you have been into a lot of cases on behalf of organizations that you are working for, and also as a consultant independently. How do you see this issues resolving themselves in the near future?
I think, see, what happens in most cases, you're right about the data confidentiality and security. What happens in most cases is, especially let's assume you're talking about, say, transaction, credit card, or FICO scores data, mortgage data, etc. I can tell you, I worked for one of the major banks, and we were building models for their CCAR, what they call the comprehensive, the review process mandated by Fed. And what they typically do in those cases is they'll actually give you a separate laptop computer where you cannot download anything, and that has access to their internal servers through a very, and obviously you need, RSA security tokens, etc. So it's a completely standalone machine where essentially all the software is installed, and you use it to basically get your work done remotely or otherwise. And that's how they do it. And obviously you have to, go through all the other NDAs and requirements, etc. And if you have stolen the data, I can tell you they will go after you. So I don't know whether that answers your question, but basically they essentially create complete standalone devices for you to access their data sources.
All right. Yeah, I guess to an extent that would answer the question for at least maybe people who may be viewing this now or later and who have the same kind of dilemmas, in house. Okay. Having said that, if there's any other quick question, we can maybe accommodate just one more, and then we'll wrap up this session for today. So I do not see any other questions offline at this point in time. So Debashish or Subhamoy, anything else that you'd like to bring up?
No, go ahead.
No, nothing from my side.
Thank you.
All right. Yeah. So thanks everyone who thanks to Abhijit and Subhamoy and for I think what has proven to be a very informative and insightful session within the time constraints that we have in our Hangout. And I think it's also, I hope it has been for those watching, and for those who may be watching it in future, it will be equally informative and insightful. So we will end this session here, and I'd like to mention that we have another session, a similar session coming up in the first week of May, on the 6th of May to be precise, which is essentially on smart search and on big data. And in fact, Debashish is one of the speakers during that session, and the speaker on smart search is David Amerland, who has done a lot of work in this area. He's written a book as well. So I hope everyone here, and some of you who are viewing and who may be interested in the topic, do join in on that date. And thank you very much for coming by and taking the time out for Hangout today. Good day and goodbye.
Bye.
Yeah, thank you. Bye.
Bye.